Hello everyone, welcome to tutorial 2. This tutorial is about time series dataset class in PyTorch forecasting and it is going to be in two parts. One is understanding time series dataset class itself and another is going to be about its methods and attributes. In second video also we will discuss about monkey patching time series dataset. So let's not get things delayed. I'll quickly show you how you can create the object and obtain the data from this class. So I'm going to walk you through the code, how you can create time series data set and how you can use it. On the screen left side, you see documentation of time series data set. Also, if you are using an older version, you can pick from here and read the documentation. In the right, I will be doing the coding. I have created a template in which I will be writing the code. First of all, I will be creating a toy data set, which is very much realistic in the real world scenarios. And later on, I will show you how you can pass it in the time series dataset class of PyTorch forecasting. So first thing first, we will be doing some imports. So I have imported few things, which is NumPy, Pandas, Torch, PyTorch forecast from PyTorch forecasting time series dataset. Apart from time series dataset, I have encoder normalizer and group normalizer. Group normalizer will be used for targets and encoder normalizer for the input features. NaN input encoder will also be used for categorical features. If you don't know why you need encoders, it is because there will be some categories, some values which will not be present in validation dataset or the testing dataset. And also machine doesn't understand characters, it understands number. That's why you have these label encoders. Also normalizers is when the range of values are too high or too low, you want to normalize it and to make it in a certain range. Similarly, this robust scalar and standard scalars are used. If you want to know what in depth they are about, you can read it on this sklearn package. Now I will be creating the data set. So for this, I just quickly initialize a seed for NumPy. Else, what will happen every time I run it, I will have some different values. So let's initialize a seed from 42. Uh, in the past, I explained you need some SKUs. Here, SKUs will be stores which will resemble store IDs and products. So I will keep this data set small. So I will have four products and three stores. I just quickly write this code and will explain you line by line how different things are being put in. I also have dates. I will keep 120 dates of days of data. I have this thing ready with me, so I just quickly paste it. So just keep this as days. Okay. So for each store and each product, I have certain store types and categories. I will also have time indexes. I won't be having any dates since I mentioned it only take time indexes, not dates. There's some random sales data generated, some price, some promotion. These are going to be some known features in the future because you know about what price you have in future and what promotion you are going to give in future. Also, there are going to be some extra data which I have also added a sample weight for each value. So I just quickly show you how this data set is created. Okay, this looks something like this. In addition to this, I will create two random variables as well. which will come handy when I create the data set and show you what special features this model can take. So how does this operate is, you need not to create embedding for each random variable. You can just simply club them and give the embedding. I am going to show you just in a bit. So I need to pass size also. Suppose size is length of the df. One won't be enough. Let me also create another variable. Okay. So I have some random variables as well. Thirdly, I want to create some missing values as well, just to show you that it works even when you have some missing values. For that, you need to activate one parameter, which is allow missing timestamps. You can also read this documentation while you do the coding. I strongly recommend you also do the coding along with me. So I, for one product and one time index, I have removed the data. I just also want to fix the max prediction length to 7 and max encoder length to 30. And I also wants to split the data into training part and validation parts. For this, I will be using this cutoff date. So if I show you what cutoff date is, 112, total time index I have 120, and uh, since indexing starts from 0, you have 119 max value, and 7 is subtracted from this, so training cutoff is set to 112. You can also adjust it to even lower number, but for now 112 should be fine. I also wants to fill missing values. Since I have some timestamps missing, there will be some missing values as well. So you can also pass some fixed values. Here you cannot pass a function, some constant filling strategy for missing values. Suppose I have sales data missing, so I can replace it with 0, and I will also be having promotions which has some missing data, and I can also replace it to 0. So this should be good. Let's make a comma. Okay. This allow missing timestamps. This constant filling strategy will only work when you pass this allow missing timestamps to true. Another thing is there are some categories as well. So you want to fill category encoder. So you want to create some categorical encoders. So first category which you have is store ID. You want to create nan label encoder, and also you can add a nan value. Suppose in validation you don't have this particular category, so that won't give error. This will create a nan value or a nan category as well at that place. So you want to make it for product ID as well. You want to make it for store type as well. And what you have normal category for the product. So you want to make it for category as well. Okay. You want to define some scalars or normalizer as well for the real values, not the category ones. So how many scalars you have? Let me check. This is category, this is all category. You have only sales and price. Okay. So for sales, I will create robust scalar, and for price, let's say I create standard scalar. Okay. One more thing I want to tell you, you can also explore what robust and standard scalar are. If you directly want to go into documentation, you can read what standard scalar is. Just if I have to quickly explain you what it is about, suppose you have values like 1, 2, 3, 4, 5, 6, and 1000, 100 or 1000. So it will do a scalar among these value and will ignore this outlier. So this is mainly about robust scalar. How it is done, there are certain quantiles created, and in this way this is done. What is the error? Unhashable. Okay, you need to pass it as a string. You need to pass it as a string now. Okay, it works now. So this is all about the preparation. Now I want to create time series data set. It's enough talking. So I just before that just quickly have a look what variables you have. You have weights, you have some random variables, you have future known values, you have sales, which is target, and you have some categories and time index, obviously. So first thing first, training data set. You want to create a data set from time series data set. What do you want to pass first? Look it here, which is the data frame. So data is df dot time index less than training cutoff. I hope you understand this. If you don't understand this, probably this tutorial is not for you, but still I explain. What I have done here is I have filtered the data where time index is less than the cutoff date, so that you have some data remaining for validation as well. Time index column is going to be time index only. Then you have target. Target is going to be sales. Group IDs are going to be store ID and product ID. Okay. Now you want to pass weights. So I have weights as well. Sample weight. Okay. Now you want to pass these things: max encoder length, min encoder length, min prediction index, min prediction length, and max prediction length. So I will ignore this min prediction index thing because I believe this can be adjusted through encoder length and prediction length only. You don't specifically need to specify min prediction index. So I have kept it as this. This is basically 30 and this is basically 7. So even I can hard code it. Earlier I have already defined as at 30 and 7. Now what you have is static categorical. So what does static categorical features you have? You have store ID and category. So these you have, so you pass like this. Okay. Now you can pass some reals as well. I don't think I have any static real, so I will keep it as it is. Now time varying known categoricals. I don't have this time known. Now what I have now what I have is time varying known reals. In future, what I know about price, okay, and I know about promotion, and I know about time indexes as well. Although you might not want to pass time indexes, but I have small data set, that's why I have passed it. Now coming to time varying unknown categories. I don't have any categories which I don't know in future. Time varying unknown reals, it is obviously going to be sales, which is our target. Now what we have variable group. This is something which I told you about. So you, for different variables, you don't want to create individual embedding, so you can directly pass them as a special group, which is going to be random variable 1 and random variable 2. Then what you have constant filling strategies. Okay, you have some values which are going to be missing. So earlier I had defined this. So if there something is nan, I can fill using this. And to activate this, I need to allow missing timestamps to true. Okay. Then what we have add relative time index. Say for TFT, which model I'm going to demonstrate next, I just do it true. So it will add relative time indexes. For this is going to help model to train at target scales. This is also something model uses. I will tell you what this is when I show you the example when this data set is created. Then another is encoder length. So between 20 to 30 there is going to be split of different encoder length. So how much it is, you can also get it in the data set, and specifically you need to set it to true. You can also set it to false. This depends on which model you are using. Then target normalizer. Obviously your target values are also going to be in different ranges. So what you can do is group normalizer. In this case, on what groups you want to do it is up to you. For now I just do it on store ID. I can also add product ID, but for now store ID should be enough. Okay, and this also shows you can pass whatever you want. Now you have they have so now they have already given what choices you have for a target normalizer. This should also work fine. They have like multiple choices, and you also want to pass categorical encoders. I guess I had already created them before, so I will pass them as it is. Then what you have a randomized length. This is used for data augmentation. So occasionally it reduces the length for some it sometimes reduces the length for some of the points, which happen to make the model more robust. But yeah, so let's keep it true as well. The last argument you have, which is predict mode. You have predict mode as true when you want to do the prediction or the inference. Else if you want to do the training, you can set it to false. So this is all about it. Where it is giving me error in weights. I already have weights. Okay, it should not be weight, it should be weight. I'm not removing the errors as well, so that you know where we get common errors. Okay, now where it is, list object has an attribute items. Okay. Okay, so I guess there is also a red line. Let's pass it as variable groups. Let's pass it as a dict, not as a list. So how can I do it? Okay, okay. I have now passed it as, now I think I need to name it something. Let's say product hierarchy, H for hierarchy. It should work fine or not. Okay, it works fine now. Okay, then I also have an assignment for you for this target normalizer. Suppose you want to create your own normalizer, how you will create. So this is going to be how you create your user defined the normalizer. So suppose def user defined normalizer. This should not be a function but a class. How you do it is up to you. I will give the answer of this in description, so check it. So one more thing which I forgot to tell you is this randomized length. Either you can pass it boolean, which is true, or you can pass it as a tuple as well. So it can also be passed something like two values of floating point 0.2 comma 0.05. So these two values come from a normal distribution. How often you want to reduce the length of the encoder. So this was one thing. Now let's move to creating the validation set. In order to create the validation set, you obviously do a validation data set. I have already created one training data set. So there is one function which is from data set. You can import the settings directly. Now all the settings of training data set are directly imported. You can pass the data frame, entire data frame. You don't want to pass just the validation data set or after the cutoff date, else how would it create the encoder part. So that's why you pass entire data set, and you also want to set the minimum prediction index, which is this. As earlier I have not passed it in validation, I will pass it, which is going to be cutoff date plus 1. Okay, so now I want to convert everything into data loader. So this will be something like this. This is basically how you do it in normal PyTorch. Okay, so this also runs. I also want to inspect how single batch looks like. So this is how you can iterate. Next iter train data loaders, very similar how you do it in PyTorch. So this, I have also seen how they return the output. If I can directly move to this or do this data loader. So this is the function which is responsible for generating the output. collate function. So this is the dictionary, which is the training and target and weight. Okay, so x comma w comma weights, and you can pass them as a tuple. Okay, so you have data, your training data. Then you also have your prediction values. You can see all are of length 7. In addition to this, you also have weights. Just have a look. You don't have weights for encoder because loss creation is only done on decoder part. You need weights associated with the label for calculating the loss. Okay, just quickly show you the keys. You have encoder categories, encoder continuous, then you have encoder target, you have encoder length. These are for encoders. Then you have decoder categories, decoder continuous values, decoder target, decoder length, decoder time index, groups, and target scales. Okay, one more thing I want to tell you is you don't have any encoder time index. This is design choice of PyTorch forecasting. They don't provide any encoder time index, so you don't do any data leakage. If you want to add encoder time index as well for some calculation, you can also do it by monkey patching, which I will show you in the later part of this video. And just also show you how typical batches look like. Suppose in training data you had a encoder, you had encoder categories. Okay, what is the shape of this? So you have 16 batch size, 30 encoder lengths which you have, and 2 because you had 2 categories. Similarly, you can check this for decoder part. So same batch size, say 7 is going to be the prediction length and 2 categories which you have. If I just quickly see what about the continuous value, so in this case they are going to be 8, not 2 or 3. And what are these categories as well? You can also check that there are multiple functions for that. Okay, now what I want to do is do a sanity check if this particular class is doing any data leakage or not. So how I do it is assert x encoder so encoder length, uh, the continuous values. So I just quickly show you. This is the encoder length, and this doesn't exceeds our max encoder length, so it is fine. You can also check similar thing for decoder part. So max prediction length, and decoder should not exceed max prediction length. One more thing, you might be wondering about one more thing. Why this 8? The continuous values which we are passed were little less. Why this? So I quickly show you about what values you have. You have encoder length, you have sales center, you have sales scale, price, promotion, time index, relative time index, and sales. One more thing I just noticed, there is one more argument lags. it just sneaked in the corner. So you can pass legs also for the targets. Suppose I pass 1, 7 and 14, and this has to be dictionary. Suppose I do it for sales. Okay. um, okay, so you can pass legs as well. And when it comes to real values, now you don't have 8, you have 11, and three more values or columns are added, which are lag of sales, which is 1, 7 and 14. So this is all for now. We also have some special methods which we are going to see in the next video, and you can see in the documentation as well. You have here methods. So all good. Have a read. Try everything what I have done once on your system as well. And what each of these method mean, we will look one by one in next video. So this is all about time series data set. In next video, we will discuss about its methods and attributes, and how you can patch few things. So thank you.